Alright, we're going to expand on our factoring knowledge to move towards another application, which is simplifying rational expressions. A rational expression is simply put a fraction. So let's begin simplifying numeric fractions. For example, 6 over 8. Now we know we could divide both of these terms by the same number, and that's essentially exactly what you're doing when you're simplifying algebraic rational expressions. So what you're doing here, you're factoring completely the numerator, factoring completely the denominator, and looking for the same number so you can cross it out. So in this case we have 2, and we have 2 that we can cross out. The reason you cross these things out is because the only operation being performed in a numerator is multiplication. There's no plus sign in there. There's no plus sign down here, so I can cross things out. So this becomes 3 over 4. Completely simplified. So we're factoring completely, making sure all we have is multiplication, and crossing out the exact same term. So let's see if we had an algebraic fraction. Say we have x squared minus 4 over x squared plus 4x plus 4. So now it is very enticing to cross out these x squareds and cross out these 4's. But we do not have multiplication in the numerator. We do not have multiplication in the denominator. So we have a subtraction sign and an addition sign. You cannot cross out across that. We have to factor first, then cancel. So let's express x minus 4 is x plus 2, x minus 2. Well, there's a product. Let's cross out. Sorry, let's factor. Make that x plus 2 times x plus 2. You can only cross out entire terms. X plus 2 is a term. X minus 2 is a term. X plus 2 is a term. X plus 2 is a term. And only if they're exact. So we're left with x minus 2 times x plus 2. Okay, let's say we had 2x minus 4y squared over 6y minus let's say 12x squared. Let's simplify this rational expression. Let's factor the numerator and factor the denominator separately, leaving us with a 2 times x minus y squared over 6 times y minus x squared. Oops, I don't know why it would be doing that. That's silly. So we can't cancel any variables because we can't factor this any further. We can't factor this any further. They're not the same. The only thing we cancel here are numbers. So let's cancel 2 with the 6, leaving us with 3 in the denominator. Notice how I circled it so I realize it's still there. So I can't continue factoring this. I can't continue factoring this. There's nothing left to cancel. So this was a boring example. So that's how you simplify rational expressions. Rational expressions can also be undefined at certain points. A fraction is undefined when you have 0 in the denominator. So just set your denominator equals 0. After you set your denominator equal to 0, that's what x cannot be, or that's what y cannot be. So for example, let's say we had x to the third plus 4x squared minus 8x plus 2 over Um, 3 plus 4x. Now, it doesn't matter what the numerator is. You can't have 0 in the denominator. So this can be as complicated as you want. This cannot be 0, because then we're dividing by 0. So get rid of the numerator and just say 3 plus 4x equals 0 and solve for x. So 4x equals negative 3 divided by 4. X equals negative 3 over 4. So that means x cannot be equal to negative 3 over 4. That says can't be equal to. It's an equal sign crossed out.